Hello and welcome to our program, Astronomy for Everyone. The topic for this month's show is the New Horizons Pluto mission. I'm sure most of you have heard something about this in the media over the last couple of months. In this program, we're going to bring you a little bit of history about Pluto and then take a look at some of these wonderful images that have been returned. With me here in the studio to bring you this information is our own Stephen Whitty.
Great to be back.
Well, the quest for Pluto really seems to have started with Percival Lowell, but he didn't start with Pluto right away. When he founded the Lowell Observatory back in 1894, his passion was Mars. He made exhaustive studies of Mars, looking at the various channels which he believed were there to support a dying population, bringing them water from the poles. Of course, that's been totally refuted. But he stayed with that line of study from 1894 until about 1906, when he switched his focus to looking for Planet X. He felt that there was another body out there in the solar system that was perturbing the orbit of Neptune, and so he took it upon himself to try and find it. Now, others were looking as well. One of them was William Pickering, who helped Lowell set up his observatory, located on Mars Hill, just outside of Flagstaff, Arizona. Now, in the study, they took photographs on glass plates. They did this for a number of years, from about 1906 to about 1916, when Lowell himself died of a massive stroke at the observatory. And in this image right here, you can see him seated by his 24-inch Alvan Clark refractor. It's a daytime shot. He happened to be studying Venus at this particular time. But his passion after 1906 was to look for Pluto. Now, he didn't have success, or so he thought. But years later, looking at some of the photographic plates that were taken before his death, they did find Pluto there in images taken in 1915. Now, with his death, his will bequeathed $1 million to the observatory to carry on his work. But his widow had other ideas. She wasn't too keen on leaving $1 million of her money there, so she contested the will, and it took about 9 years to settle it, which ate up most of the $1 million. Work still continued, but not at the pace that Lowell had wanted. Now we're up to 1929 with the arrival of Clyde Tombaugh, a 22-year-old Illinois farmer and amateur astronomer. You can see Mr. Tombaugh there at one of the telescopes at the observatory. Now, Mr. Tombaugh was sort of self-taught, and he didn't seem to really have the credentials, Stephen, to get this kind of a job. So how did that come about?
Yeah, so I attended a lecture by Tombaugh at the Boston Museum of Science in the early 90s. And he said it was kind of strange. He had ground his own 12-inch, I believe, mirror for his own telescope, which he used for many years. And he needed to silver the mirror. Well, that takes special equipment. You need a vacuum chamber and so on. And so he wrote a letter to, I believe it was the University of Arizona, and he asked them for advice on how to get his mirror silvered. And they sent him a cryptic letter back saying, "Are you in good health?" It turns out that doing the kind of observing that they wanted somebody to do requires somebody with quite a bit of endurance, but also the knowledge of astronomy. So that's the sort of backdoor way that he got the job.
Well, he spent 10 months photographing sections of the sky and studying the plates. Images were taken about a week apart, and here you see him at the blink comparator. They could look between the two images, and anything that moved would flip back and forth, standing out quite clearly. Lowell had used a magnifying glass. Now here, these are the actual two glass plates where Pluto was discovered. You can see the two arrows pointing towards Pluto and how that object moved in about a week's time.
Of course, the arrows weren't there on the plates. That's been
We've added
later.
those just
Yeah, so that you could see them.
folks could see them. And these were the two images, as I said, that were used. And these were basically the images of Pluto that we had for decades, basically until the Hubble Space Telescope came along and provided us with a little bit better view. In this image here, we can see Pluto and its largest moon, Charon, just down there at about the 4 or 5 o'clock position. It also pictured our two of the newer moons that were discovered at the time, middle of the first decade of the 21st century, Nix and Hydra. So this way, we've expanded what we can see with Pluto up to that time. And but now with New Horizons, we've really expanded our horizons, pardon the pun. This is a picture of the spacecraft right here. There are actually 7 instruments on board this craft. There are 2 cameras, one high-res black and white, the other a color and infrared. There's a UV mapping spectrometer, a solar wind spectrometer, a particle spectrometer, that's tough to say 3 times in a row, a radiometer, and a student dust collector. It doesn't collect student dust. It was a dust collector designed by students. Now, New Horizons was launched back in January of 2006. You can see it taking off there from Florida. And next we'll show you its path as it left the Earth and traveled out. Leaving here in 2006, it got a gravity boost from Jupiter in February of 2007. And just this past July 14th, it made its closest approach to Pluto.
And what a trip it was.
Indeed, the ultimate trip. So what we're going to do here is take a quick break,
Okay.
because we want to save as much time as possible for some of these great images. If you have us a question, send us an email. We'll have the email down at the bottom of your screen. And coming up next is Term of the Month with Stephen, and then after that, we'll be back with some great images of Pluto. So don't go away. Thanks, Stephen, and welcome back. We're here to show you some of the early returns from New Horizons. Stephen is with me here once again. We're going to talk about some of these fascinating pictures that have been returned from the former planet, now dwarf planet.
Yeah, so we've only got 5% of the data back. We're going to be waiting for 16 months to get all of the data. So this is all preliminary.
Okay. Is there that much data, or does NASA have bandwidth issues?
Well, in some ways, it's a little bit of both. When you're out well past the orbit of Neptune, it is quite difficult to get very many bits out. I know that Voyager 1 had gotten down to 30 bits per second, so that's really not very much. And New Horizons will do better because it has a better transmitter and more power, but it's still a long ways out.
All right, well, let's get to those images. This first one is what we've all been waiting for, this actual look at Pluto. It's, you can see some of the surface features here. What I think is the most interesting is that light-colored area just to the right of center that they've been calling the heart of Pluto.
Yeah, it is quite interesting. Another thing that isn't not necessarily obvious from the picture, that you learn from the picture, is how big is Pluto? And it turns out to be slightly bigger than they thought it was.
I think it's just under 1,500 miles in diameter.
Yeah, I knew it in kilometers. Now I don't. Anyway.
But this bright area is actually an area that they feel is just a large field of frost.
Yeah, very likely. But and the interesting thing is that it's for the most part very smooth, which suggests that it's a young feature, a young surface feature. And yet there are also craters that are obviously, and mountains that are also quite old. So you have young and old features on the same body. This is already a very interesting geological place.
And the frost itself isn't water like we have here on Earth. It's a frost of methane, carbon monoxide, and nitrogen, which are the gases found in the atmosphere of Pluto.
And the atmosphere of Pluto, there is one.
Yes,
it's very thin. It is 10 microbars. So a bar is the pressure at sea level on Earth. A micro is the 1/millionth prefix. So this is only 10 times bigger than a millionth of. So, you know, if you were to go to Pluto, well, the nitrogen might be familiar because we have quite a bit of nitrogen in our atmosphere, but there's so little of it. It's a fairly decent vacuum.
Yeah. Our next image, this was just before the moment of closest approach back on July 14th.
Mm-hmm. So it should be noted that like the Earth and the Moon, Pluto and Charon have a single face. They both have a single face that faces the other. So one face of Pluto always can be seen if you were standing on Charon, and vice versa.
Tidally locked.
Tidally locked in both directions.
Next, we have, this is a close-up. We can see a couple of mountain ranges that they're showing here, both Norgay and Hillary. Hillary, of course, the first man to scale Mount Everest, and Norgay was his companion.
And we've got a nod to Sputnik.
Yes, we do.
You know, the Russians made it to the moon before we did, and got something into space, Sputnik, that sort of got us, really woke us up.
Now, in the next image we're going to see, we'll also have some mountain ranges. What's interesting there, towards the right and down a little bit, you see some very rugged terrain, and then to the left and up, very smooth areas. But what's interesting to note about those mountains is they are not made of rock. They are made of water ice. And at the temperatures on Pluto, which approach minus 400 degrees Fahrenheit, water ice is as hard as rock.
Yeah, the other idea would be, you know, you've got a nitrogen atmosphere, perhaps they could be made of frozen nitrogen, but it turns out that these mountains are too steep to be made of frozen nitrogen. That would be sort of too slushy. It wouldn't be strong enough.
Exactly, exactly. So next, this is off from the edge of the previous picture. What's interesting about this is we look into the Sputnik Planum, that's the smooth, lighter area that you see there. We can see what appears to be something flowing, and what we see here are glaciers made up primarily of nitrogen ice that are operating much in the same manner as we see here on Earth in Greenland or Antarctica.
Yeah, one of the things that we expect as Pluto gets farther and farther from the sun, because it recently meaning two decades ago, was as close to the sun as it gets. So it's probably still close to as warm as it gets, but we expect that as it goes further and further away from the sun, that it'll cool down. That process will take some time. There'll be some lag, just like summer lags the solstice.
It's warmer in fall than it is here in spring because of that.
That's right. There's some lag.
Thermal lag.
Right. Now we have big oceans to do that, but Pluto has a planet to do that, so
it does.
It happens.
It has some mass. This picture is fascinating. We can look at sort of these polygon shapes. It looks like there's little troughs running in between some of them, and in other areas, there must be the tops of little hills or some other type of land feature poking up through.
And when you have these little troughs, that's when I expect that you've got some sort of process where the whole surface has subsided. It has sunk a little bit. And I'm not sure if this is it, but some scientists on Alan Stern's team have said that there may be evidence for a subsurface liquid body of some sort on Pluto, and that would be exciting.
Another hypothesis I've heard about these shapes is the process similar to when mud dries. You see it fracturing apart.
Yeah,
Very similar to what
exactly.
we see right here. It'll be interesting to see what they're able to find out in the months ahead.
That's right. So with the times 20 the data that we have now, we should be able to answer a lot of these questions.
I would think so.
In addition to just images, we have spectral images, so we know the constituent chemicals of a lot of things.
Exactly.
So, for example, acetylene has been discovered in Pluto's thin atmosphere. There's another thing that's like ethylene or something. Yeah, ethylene has also been discovered. So in relatively small amounts, it's mostly nitrogen.
Okay. In our next image, this is Pluto's largest moon, Charon, or Charon. It's both pronunciations I've heard. Through the center part of it there's a ridge that drops down into a smoother area down to the farther right. This looks like some sort of geologic activity, something that we would call plate tectonics here on Earth, but we don't think that's happening on Charon.
Not that I know of, but again, if you had a subsurface liquid, you could in fact have plate tectonics. And we do know of another body other than Earth that does that. Titan has a surface that entirely floats on some sort of an ocean.
And Europa, one of the moons of Jupiter as well.
Yeah. But unlike Europa, where we're pretty sure that there's liquid water of some sort underneath there, for Titan, we know that the entire surface moves under the force of the wind.
Fascinating.
Yeah, very strange.
The image that we'll bring back right here for you is interesting. You can see it's an inset, and up at the top left corner there is a peak within a crater. We see this typically with impact craters that can create a central peak with the impact of a fairly large.
Yeah, but this is very strange even for that. Very strange.
It is, and we can also see some cratering here, but one of the things that surprised scientists was the fact that the relative lack of cratering.
Which suggests that either there's nothing hitting it, which seems unlikely, or it's got a young surface, so there may be some way that the surface gets rejuvenated from time to time. And there are a bunch of ways that could happen. It does get it does get slightly closer to the sun than Neptune, which is still pretty cold.
Oh yeah. When you're getting close to minus 400 degrees Fahrenheit, it's pretty cold.
That's right, yeah. But maybe something there does something with nitrogen and it becomes gas and then falls to the surface and so on.
You never know. This next image is of two of Pluto's other moons. You've got Nix on the left and Hydra on the right. They are slightly out of focus, so don't try and adjust your set. You can see a little bit of colorizing there with Nix. Scientists think that might be an impact crater that highlights that little rose reddish color there on Nix on the left. And Hydra on the right almost reminds me of the mitten of the Lower Peninsula of Michigan, doesn't it?
Yeah, it could be.
There a little
could
bit.
be. Maybe that's what they were thinking.
Anyway, there are two more moons. Images of those, if I understood correctly, will be back sometime in the middle of next month, mid-October.
Okay.
So we will see those.
Yeah, what's interesting is that we know that we have the images, or at least New Horizons has them, and we also know that no other moons were found. 15 times the sensitivity of the Hubble Space Telescope and no more moons. And that is a surprise to the entire team. Alan Stern actually made a prediction just a few months ago where he said, we've got 5 moons, we expect more. We might have a ring system, we might have this other sort of stuff. And as far as we know at the moment, no is the answer. So we're limited to the 5 moons.
The 5 moons and no rings noticed so far.
It's not so far, yeah. Maybe in the full data.
New Horizons has completed its primary mission, so you wonder what happens. Well, New Horizons is going to continue on out into the Kuiper Belt, which is the region where Pluto is. It's the region of the solar system beyond the orbit of Neptune, to look for some more Kuiper Belt objects. Now, we already know of several of them, Eris, Haumea, Sedna, for example. But they're using the Hubble Space Telescope to try to find some likely candidates that they can steer New Horizons toward with the fuel that it has available to it. As far as how long the mission can last, they say it has enough power within the unit itself to keep operating into the mid-30s, so another 15, 20 years. But all of that, of course, depends on the funding. As they say, it's all about the funding.
Yeah, another object was chosen and has been slated for New Horizons to visit.
Now, some of these objects are quite small, as far as I understand, maybe 10 times the size of a comet, but only 2% the size of Pluto. So
right, they're so they're tiny by solar system standards, sure.
well, we hope you've enjoyed this update on New Horizons Pluto. As more data comes in over the next 16 months, we'll do our best to try to bring you this information. Visit our club website. We'll have the address for you down there at the bottom of the screen. As part of the website, you can click on the link for Astronomy for Everyone. And there you will find a list of all of the episodes going all the way back to episode number 1.
My favorite way of finding episodes on YouTube is to do a Google search, and you say YouTube : and then Astronomy for Everyone, just spell it out with the spaces and everything, and then give the month and the year that you want. So spell out the month, for example, September 2015, and it should just come up as the first thing in the list, and you can click on it and watch it.
Great. We do want to remind you about Astronomy at the Beach. We mentioned it last month. It's coming up at the end of this month on the 25th and the 26th. It's a Friday, Saturday at Kensington Metro Park's Maple Beach location. It'll be over 2 nights, and our main speaker for this year's program is Dr. Nicole Zellner, a professor at Albion College here in Michigan. She is a member of the faculty there in the physics department, and her talk will be about moons and planets. She's a very engaging speaker, and I hope you can join us for this event. It runs from 6 p.m. till midnight, cloudy or clear, though we're hoping for the clear. The event itself is free. You can see a couple of images from Astronomy at the Beach. The only sure expense would be the park entry fee for a day, which is $7, I believe. But please join us. We look forward to seeing you, and we want to thank you for watching. Coming up next, of course, is Stephen with What's Up in the Night Sky for September.
Thanks, Don. The term of the month for September 2015 is Imaging Spectrometer. Now, an imaging spectrometer is a spectrometer that you have a spectrometer at every point in an image. Let's start with a rainbow. A rainbow splits white light up into colors. Now, your eyes detect red, green, and blue. You see more colors than that because your eyes pick up how much red, how much green, and so on, and it comes up with more colors. Your brain just does it. Now, a spectrometer has more colors than the 3 that your eyes have. A spectrometer could have tens, hundreds, or even thousands of colors that it can detect. But a spectrometer is 1 pixel, 1 dot. An imaging spectrometer has basically a spectrometer at every position, every pixel, every dot in the picture. So, an imaging spectrometer. So there are 2 imaging spectrometers on the New Horizons mission. Pictured is Ralph. Ralph and Alice are very similar, so I only have the one. They have a 2.4-inch telescope, which is 6 centimeters in diameter, and the spectrometers have 1,024 bands. Alice has these bands in the far and extreme ultraviolet, so these are wavelengths that are shorter than violet in the rainbow, in the visible. And Ralph has 1,024 bands, but in the infrared. So these are in longer wavelengths than the red part of the visible spectrum. Now, ALICE is named ALICE because it is very similar to ESA's Rosetta mission, which goes to the comet 67P. Ralph is designed after Alice and is named after Alice's husband in The Honeymooners. So you have Alice and Ralph Cramden. And that is Imaging Spectrometer, the term of the month for September 2015. Back to you, Don. What's up in the night time for September 2015? The days are still getting shorter as we head toward the winter solstice. The third quarter moon is on the 5th, the new moon is on the 13th, the first quarter is on the 21st, and the full moon is on the 27th. This is when the moon is at perigee, so it's a little bit bigger than usual. And we also have a total lunar eclipse that starts around 9 p.m. In Michigan, we get to see it when the moon rises. So it starts with the moon rising. So the shadow of the Earth is on the moon. Mercury has its maximum elongation here, shown here on the 4th of September. And now Mercury sets at 8:53, but we're here a little bit earlier so that it's up in the sky before sunset. Venus rises at, over the course of the month from a little after 5 to just a little bit before 4 as the month goes on. Mars rises a little before 5 to a little bit before 4 as the month goes on, so it's in a very similar position. And Jupiter, even a little earlier. However, we lose Jupiter, and so we've lost Jupiter. We're just gaining Jupiter, and so we see it in the morning at 5 a.m. Saturn, shown here on the 1st, because that's when it's best in the sky over the month, sets at 11:30 at the beginning of the month and around 9:40 at the end of the month. But Saturn is, so we're going to be losing Saturn pretty soon. So here at Astronomy for Everyone, astronomy is free, but we may tax your brain a little bit.